Hello and welcome back to our videos on the omega theta. Today I'm going to show you how our mapping stage works. So this mapping stage is an R5 stage. It has one motor that can move the stage in and out, and it has one motor that rotates the top point. That way we can reach any point of this 300mm diameter stage without it sticking out over the base table and hitting things inside of the goniometer. I've already placed my silicon wafer sample in the diffractometer and a piece of paper on top. Now I'm going to move to the center position of the wafer and align on it once the movement is done. Okay, that's done. Remove our piece of paper. Close the door again. And then I'm going to start measuring our demo pattern, which is just 7 points, because we don't want to wait too long with this. And start. Okay, and with that the measurement is done, let's go have a look at the results. So now we see the results of our little 7-point mapping. We can see the tilt in every point. I can pick in this drop-down list, show you the tilt direction, the ref offset, and all these other values like the laser tilt. And we can go back to the tilt again, because you will see that the color scale here changes a bit dramatically because it's an auto-scaled color scale. Our actual difference away from the average is not that big, but it might look bigger because of the auto-scaling color scale. If we want a different pattern, we can just define it under Settings, Mapping Patterns. The software will let you define just about any pattern. Yes, we tell it what the wafer type round is. In this case, it's a round wafer with a flat on the left. 150mm diameter is correct. I like setting the flat depth a little bigger so we're not too close to the edge somewhere. And in this case, let's do a 5x5 line scan, create a pattern. So now we have a pattern, it draws where we will measure on the wafer. And we can change that up, for example, increase the border to 10mm. Press create coordinates, it looks like this. I can also make a star pattern or hexagon. And I need to define the position of the wafer on the table. Okay. Now this was just a 7-point demonstration pattern, but I can also show you some data we recorded earlier on a silicon carbide wafer. And that's this. Here we measured several hundred points. And you can see in this case we need to zoom in to see the individual tilts. Now it does look like we have a bit of a pattern here. Yeah, higher tilt here, lower tilt on this side. But if you look at the numbers next to the color scale, you see that we're going from 3.95 to 4.08 degrees. So over the whole wafer, there's not that much variance at all. Yeah, and again, we can just go through the tilt direction, which is largely homogeneous. The ref offset, which jumps back between plus and minus 15 degrees, but that's probably just depending on which reference direction was closer to the actually measured position. And alright, this was a quick introduction to our mapping stage, and I hope I can see you again next time.